Okay, so we're going to be practicing logarithmic functions, basically using the logarithmic form to exponential form and the identities for logarithms. Okay, so I've rewrote them so you can see them. So here I have the logarithmic form, log base b of x equals y, and its exponential form is b to the y equals x. Now, one easy way to change it from its logarithmic form to its exponential is using kind of like this circle pattern, because it's going to be b to the y power equals x. So we kind of use this circle where it's the base to this power equals x. And you can see how that translates over here. Okay? And then we also have these properties here that we talked about in the notes. Okay? Now, example number 1 asks us to evaluate each logarithm. Okay? Using this idea, so we could say, I'm going to put this equal to say y, so we can create our exponential form. So I'm going to switch this to its exponential form. So it's going to be 5 to the y, so 5 to the y power equals 1 over 25. Okay? Now, basically this is saying 5 to what power equals 1 over 25. Now, a formula that you should have and know is this power formula. If you have a base to a negative power, that's the same thing as 1 over x to the n. A negative power actually takes the reciprocal of a number. Okay? So it also works the other way, where if I have something in the denominator like here, I can move it to the numerator by making its power negative. So that's the formula I'm going to use to help me figure out this, because I'm going to rewrite 1 over 25 to 1 over 5 squared. Because everybody will agree with me, 25 is indeed 5 squared. And then I can rewrite that as 5 to the negative 2 power. Okay? Well, using that idea, that means that if I rewrite this, that means 5 to the y power equals 5 to the negative 2 power. Which means since they both have the same base, that y has to equal negative 2. And sure enough, if you take 5 to the negative 2 power, the negative is going to move the 5 to the bottom, and the 2 is going to square it, which gives you 1 over 25. Okay? Now, we're going to use the same idea here. So again, I'm going to say this is equal to y. I'm going to change this color to red. And I'm going to rewrite it in its exponential form. So it's going to be 3 to the y equals the square root of 3. So 3 to the y equals the square root of 3. Now, again, another one of these formulas that you should know is x to the n over m power. And this is how you deal with a fraction power. That's the same thing as the m root of x to the n. These two formulas right here, I always tell my pre-cal kids, because they use a 5-subject notebook, that you should have those two formulas written down on the first divider in your 5-subject notebook, so that if you ever need those, they're going to be there. And that's where we write down basically all of these formulas that we see that we need, that we probably are not going to remember right off the top of our head. Okay? But we're going to use this root power, the second one, to change my square root into a power. So the square root always has this hidden 2 right there. We just don't write it because if it doesn't say, it's automatically 2. And we have 3 to the 1 power. So using my formula, the root power, this 2, is going to be the denominator and the 1 is my numerator. So I can rewrite this as 3 to the 1/2 power, which is something they went over in Algebra 2. The square root is the 1/2 power. So again, that means 3 to the y equals 3 to the 1/2 power, which means y equals 1/2, which now makes sense because 3 to the 1/2 power is the square root of 3. Okay? So those are a little more complicated only because we needed these two formulas that you might not remember off the top of your head. Now for this part, evaluate each expression. We're going to be using these properties right here to do that. Okay? So where we have the identities, this is basically b to the 0 power. Any number to the 0 power is 1. Any number to the 1 power is itself. And then the two inverse properties. These are the inverse properties. Okay? So we're going to look here. Natural log of e to the 7. This is the same thing as log base e of e to the 7. And this is my inverse identity because the bases are the same, which means what I'm left with whatever is in the exponent. So my answer is 7. Again, this one, e, the natural log is log base e 5. And again, this is the inverse property. Since the bases are the same, I'm left with what's here, so this is 5. And here, this last one is also the inverse property because when they don't tell us what the base of the logarithm is, we automatically know it's 10, and since the bases are the same, we're left with whatever is there, which is 13. Okay, so these are just the application of our inverse properties. Now, let's look at these. So log base 7 of 7, that is 1. And again, going back up here, I can show you that that's this property right here. If this number and this number are the same, the identity says that it's 1. Because again, if you switch it to its exponential form, if you go, you said log base 7 of 7 equals y. This is 7 to the y power equals 7. Well, this is 7 to the first power, so y equals 1. So either way, it kind of makes sense. So you can either change it to its exponential and just use a little logic and reasoning, or you can just have the identities memorized. Number 2 is just like what we did in part C over here. Since the bases are the same, I'm left with 5x because this has got a 10 right there. Again, this is the identity for inverses. So the base is the same, 3 and 3, so I'm left with 2. Okay, number 4. This one, I'm going to have to change it to its exponential. Or think of it this way, 6 to what power gives me 36? But if I change it to its exponential, it's 6 to the y power equals 36. And again, this is 6y. 36 is 6 squared. So y equals 2. You can think of it that way. Okay? And then this one the same way. I'm going to change it to its exponential. So 3 to the y equals 1 over 81. Well, this is using that negative power, but everybody should agree with me that 81 is the same thing as 3 to the 4th power. So this is 1 over 3 to the 4th. Using that negative power, this is 3 to the negative 4 power. So that means 3 to the y equals 3 to the negative 4. So y is negative 4. And this one is our inverse identity because we know that the natural log is log base e. And basically it says if you have the base and this base the same, you're left with whatever is here. So we're left with x squared. So you can do these in a couple different ways. Okay, so you could either change them to their exponentials and solve it that way, or you can actually just memorize the formulas. Okay, it's totally up to you.